All right, so we can use intermolecular forces to help separate components in a solution or a mixture. So chromatography is one of those things that is used a lot in labs. So we're going to talk about simple chromatography, but there's a lot of different types of chromatography, like liquid chromatography. There's HPLC, which is just a high performance liquid chromatography, gas chromatography, and that's actually used a lot in labs to separate components of a mixture apart from each other so that you can do more analysis on it. So chromatography always involves two phases, a stationary phase and a mobile phase. So with simple chromatography, you're going to have a stationary phase, which is usually some sort of plate, or it could be filter paper, but it's the stationary phase is what stays still. Then there's a mobile phase. So the mobile phase will be a liquid. So with just simple chromatography, it's a liquid, but you can use gases as well. So the mobile phase will move. Okay, so it essentially, what happens is you'll have a mixture. Okay, so in this case, we're looking at an ink spot, and we're going to have a stationary phase and a mobile phase. So the mobile phase is the solvent. And what will end up happening is the mobile phase will run up the stationary phase. So those water molecules will travel up the stationary phase. And then that mixture, okay, whatever's in this, those components will start to be separated from each other. And the way that they get separated is how attracted they are to the mobile phase. If they're attracted to the mobile phase, they'll run up the stationary phase with it. So the higher they get up the paper, the more attracted they were to the water molecules. So if I look right here, this is a separation of my mixture of dyes. I can tell that the yellow dye right here is actually strongly attracted to the water because it's pretty much run up the paper with the water molecules. If I look down here, this purple dye is not as attracted to the water molecules. So what this tells me is that the yellow dye is more polar than the purple dye. The purple dye is probably less polar. So if you're given a diagram of chromatography, you need to pay attention. Okay, so what is your mobile phase made of? Is it polar or nonpolar? Okay, if it's a nonpolar substance, whatever is running up with the nonpolar substance is more attracted to it, so it's more likely to be nonpolar. Now, we have something that we can actually measure with our chromatography, and that's called a retention factor. Okay, so the way that you get the retention factor is that you take the distance traveled from the compound divided by the distance traveled by the solvent. So if I'm looking at this yellow dye right here, or the red dye, I would measure the distance that the red dye traveled, and then I would compare that to the distance traveled by the water or the solvent. Okay, so a higher retention factor indicates that it's more attracted to the solvent. Now, we also have distillation. Distillation is where you take a solution and you're boiling it very, very slowly. Okay, so each component in this solution will have a different boiling point. So what'll happen is that you'll get to that first boiling point, it'll vaporize, it'll go through the condensation tube, and then liquid will appear at the end. Okay, if it appears first, so like you'll boil it, and then you'll slowly start to raise the temperature again, get to a new boiling point, and then you can collect the new liquid. So that's how you're separating it. You're separating it based on the boiling point. So if you have a substance with a higher IMF, the boiling point is going to be greater and you're not going to get it out of the tube first. The first one that appears out will have a lower boiling point, which means that its IMF is weaker.